Today we will see how to construct a PDA from a given context-free grammar. So we'll see the theorem here. Given a context-free grammar G is equal to BTPS, there exists a PDA, that is push down automata machine, such that language L of G is equal to language of that is whatever is the language generated by PDA, language generated is equal to the language accepted by the PDA machine. So the proof is by constructing a PDA. Let M is equal to Q sigma tau delta Q naught F be a PDA, where Q is equal to Q naught F. The PDA can be converted into equivalent grammar. As shown below, there are certain steps to be followed. First step says that the given grammar should be in a GNF form. What is this GNF form? All the productions in a grammar should be of the form A produces A alpha. That is, all the productions should be of the form A produces A alpha. What is this alpha? Alpha is a variable star. All the productions should be of the form. When we say it is in a GNF form, all the productions should be of the form A produces A alpha, where A is a variable, is a terminal, alpha variable star. There can be a zero or more occurrences of variables, but they should have a single terminal. So first step is to convert the given grammar into GNF. If it is in GNF, proceed further. If it is not GNF, we have to convert it to a GNF, then further proceed. Push the start symbol of grammar G into the stack. The transition can be written. How do we write? First step is says that push the start symbol S of grammar G into the stack. That is, first step is you are in the initial state Q naught, nothing, no input symbol, nothing, no contents of the stack. We are going to push the start symbol S onto the stack. Change the state to Q1, push the start symbol S onto the stack. So you are in the start state Q naught without consuming any input. When the stack is empty, change the state to Q1, replace, push the S onto the stack. Then next step. For every production of the form A produces A alpha, as I said, when we say it is in a GNF, all the production should be of the form A produces A alpha. Introduce the following transitions. That is, you are in the state Q1, input symbol is A, when top of the stack is A, is equal to Q1 comma, what all variables we are, that has to be pushed onto the stack. Similarly, that is replace A onto the stack with RHS with all these productions. If A produces epsilon is a production, introduce the transition of the form. If there is a production of the form, if A produces epsilon, then introduce the transition of the form Q comma epsilon comma A is equal to Q comma epsilon. That is, A produces epsilon. If there is any production of the form A produces epsilon, then introduce the transition of the form Q comma epsilon comma A is equal to Q comma epsilon, whichever the state is there, that has to be written. Finally, in state Q1, without consuming any input, change the state to final state we need to write. So finally, in the state Q1, without consuming any input, the state to QF, which is an acceptance, the transition for this is of the form Q1 comma epsilon is equal to QF epsilon. Final state we need to write. When the input is empty, top of the stack is empty, change the state to QF final state, and the contents of the both are empty. We'll see one problem. For the below grammar, S produces A, B, C, A produces A, B or A, B produces B, A or B, C produces A. Obtain the corresponding PDA. Check whether the given grammar is in GNF. First step is to check whether the given grammar is in a GNF. Yes, the given grammar is in GNF. That is, a terminal followed by variable, a terminal followed by variable, a terminal followed by variable, a terminal. Here comes B produces terminal followed by variable, terminal, only terminal. So the given grammar is in GNF. First step is you should be in the start state Q naught. Input is epsilon, top of the stack is epsilon. Change the state to Q1, push this S onto the stack. So according to that, push the start symbol S onto the stack, change the state to Q1. So Q naught epsilon is equal to Q1 S. This is the first step. So for any of the given, first check whether it is in GNF. Once it is checked in GNF, first we need to put the start symbol S onto the stack. Here S is there. If in some grammar there may be E is the start symbol, whichever is the start symbol, first push that into the stack. Once that is pushed onto the stack, next step is for each production of the form A produces A alpha. That is, alpha belongs to terminal star, variable star. Alpha belongs to variable star. So for each production of the form A produces A alpha, introduce the transition. That is, you are in the state, because now you have changed the state to Q1. You are in the state Q1. Input is A because first is the terminal, and top of the stack is A is equal to Q1 comma alpha. Whatever we have here on the right hand side of the production, that has to be written here, Q1 comma alpha. This can be shown as shown below. Say for example, consider this one. S produces, first take the first production. S produces S, A, B, C. This is that. So what we'll write, how in which state you are? You are in the state Q1. We are in the state Q1. Input is A. S is producing. So A, S. B in the state Q1 itself. Replace this alpha. This is our alpha, A alpha. This is our alpha. So Q1 comma A, B, C. Then consider the next production. A produces AB. Again, it is in the GNF form. What we have to do? You are in the state Q1 itself. Here you check the terminal here. It is A, comma, what is producing? A is producing AB. A will be there, which is equal to, you be in the state Q1 itself, and this alpha. This is our alpha. So that is Q1 comma B. Next production, A produces A, only terminal, Q1 comma A is equal to Q1 epsilon, because we don't have any variables here. The next, B produces BA, same thing here. Q1 input terminal is B, comma B is equal to Q1 comma A. This is a A alpha. A. The next, B produces B. B produces B, delta Q1 comma B is equal to Q1 comma epsilon, because we don't have any terminals or variables over here. So we'll write it as Q1 comma B is equal to Q1 comma epsilon. Then C produces A, same thing, A comma C. There are no more further variables, so we'll write it as Q1 comma epsilon. Step 3, finally in state Q1, without consuming any input, change the state to QF, because everything is done which is accepting state. Then Q1 comma epsilon is equal to QF comma epsilon. That is accepted. So the PDA, write all the transitions of a PDA, Q0, Q1, QF. We have to write all the tuples, Q, sigma, tau, delta, Q0, F. Q0, Q1, QF are the states. Input alphabets are A comma B. Tau, what all we are pushing into the stack? S comma A comma B comma C. All these are pushing into the stack. Delta, write all the transition functions here. Whatever we have got in the previous step, which is the start state. Q0 is the start state, and QF is the final state. We'll check whether it is whatever we have converted the given CFG to PDA. Both of them should accept the same string. Say for example, I have considered the string AA, BBA. So we'll start with this production. S produces A, B, C. It is there in the given grammar. You check here. Here it is. S produces. Here it is A, B, C. A, B, C. According to that, we are writing here. S produces A, B, C. Replace this A by A, B, C. So again, if we start on applying those derivations, we'll get the final string A, B, A. Similar to that, here also we have these things. We want these things. Yes, delta Q comma A comma S. Check here. A is replaced by ABC, BBC. So further we'll get it as ABC. That is equal to, what are the derivations replacement, how we have done in a derivation tree. According to that, we'll get the string BBA. So the same string has to be accepted by PDA. So we'll see the instantaneous description. You are in the state Q0, BBA, comma epsilon. So first step is change the state to Q1. push S onto the stack. So same thing we have done. Change the state to Q1. We have pushed S onto the stack. Next, you are in the state Q1. Input is A. Top of the stack is S. You are in the state Q1. Input is A. Top of the stack is S means be in the state Q1. Let the stack contents be A, B, C. See here, A, B, C. Now you are in the state Q1. Input is B. Top of the stack is also B. Input is B. Top of the stack is B. Two options are there. Q1A or Q1 epsilon. According to the requirement, we are going to write here. So here what you have done, Q1 epsilon. So same thing, you apply all those transitions what we have got in the previous step. So apply and check, you will get at the end, you are able to reach to a final state. If you are able to reach to a final state, we say that the string is accepted by the PDA. Thank you.